All right, so we've got some graphs with some possibly proportional relationships. And so I'm going to go ahead and walk through problem number one. A lot of them are just kind of writing out answers. So if I need to draw something, I will, but for the most part, I'm going to be explaining things. So part A says, what does the point 5, 290 represent in the context of the situation? So those are going to be determined by the x-axis and the y-axis, really. And so if you notice on the x-axis, it says time in seconds, and then on the y-axis, it says distance in feet. So each of those numbers represent one of those two things, and that's based on the scale. So the 0.5, 290 would represent 5 seconds, right? Because you see, if you draw a line straight down from that point, it lines up with 5. So 5 seconds and 290 feet. Okay, so that'll be the answer to problem, or to part A. 0.5, 290 represents that a jaguar can travel 290 feet in 5 seconds. Okay, something very similar with part B. What does the 0.3, 174 mean? In the context of the situation, it means that a jaguar can travel 174 feet in 3 seconds. All right, part C, is the distance run by the jaguar proportional to the time? Explain why or why not. Okay, so we haven't talked about this in a while, but if you guys remember, we've got an x-axis and a y-axis, and our relationship is a straight line. Oop, that is not straight. Let me undo that. If it is a straight line that travels through the origin, remember the origin is that spot right there. Okay, if it's a straight line that travels through the origin, it is a proportional relationship. Okay, so this is a proportional relationship. It does do that, and then you can explain why or why not by talking about straight line that travels through the origin. Okay. And then lastly, it says write an equation to represent the distance run by the jaguar. Okay, so we're going to say y is the amount of distance run, and so we're going to have to find. Remember, we're basing this off of the y equals k times x framework. Okay, we haven't seen this in a while, but this is the situation where it's used. Okay, so this is one of our axes, and then this is the other one of our axes. Okay, so and then this right here, k, is the constant of proportionality. So we have to find that first by dividing. So I'm going to say 58 divided by 1, and then just to compare, I'm going to do 290 divided by 5, just to make sure it's the same. 58 divided by 1 is 58. And then 290 divided by 5 is also 58. Okay, so our constant of proportionality is 58. And so that's what's going to be substituted in for the k. So we're going to say y equals 58 times x. And then let's kind of label these real quick. Okay, so if you take a look, if you take the amount of time, x is the amount of time in seconds. Right? If you take the amount of seconds that the jaguar runs and multiply it by 58 on a graph, you're gonna get the distance on the graph. Okay, so this is how to read that. If you take the amount of time in seconds the jaguar runs, multiply it by 58, you're gonna get the distance. All right. So you're gonna use this framework anytime that you've got a proportional relationship. Okay. So thanks for watching, guys. I will see you all tomorrow.